Okay, so welcome back to another video. So here we want to find all real solutions x such that x to the power 4 plus 4x minus 1 is equal to 0. Seems pretty basic, right? Well, this isn't exactly like a quadratic polynomial or a cubic polynomial or even a linear function from 1. This in this format is what's known as a quartic formula, where the polynomial's leading coefficient is at x equals 4. And you can also have the other coefficients be non-zero, but for it to be a quartic function, it can't be that the leading coefficient, where it's 4, has to be non-zero. So quartic functions, the general solutions, it's put it this way, it's kind of difficult, and the general solutions is kind of long. It isn't exactly kind of like if you were to apply quadratic formulas, or well, that's more of the easier. Even cubic formulas, specifically Cardano's formula for finding solutions of cubic polynomials, is difficult and long to even expand out if you were to find out if you were to find its general form of solutions using some of its non-zero constants. But we don't need to worry about this too much. This is I guess in a sense, a little bit easier to work with, because in one sense we can actually do a little bit of rewriting and then add a zero term, because that's basically the approach on how to for specifically how we're going to solve for our values real solutions of this function over here. And if anything, if we continue forward, we are going to apply some the quadratic formula to actually help find the solutions of the real solutions of this polynomial. So nothing more to that. So let's actually just jump right in. So what I'm going to do first is we're actually going to add and subtract a 2x squared and add and subtract 1. So we have x to the power 4. Add this with 2x squared. Add this with 1, then subtract 2x squared, subtract 1, add this with 4x, then subtract 1. Let this, that's going to be equal to 0. Then we can actually factor this out. This is if you unfoil, so we have a x squared plus 1 and then quantity squared. That's how we get this expansion for the first 3 terms over here. Okay, and let me actually just combine some terms over here. So this means we have minus 2x square, and let's add this with 4x, and then minus 1 minus 1 minus 2 equals 0. Keep going further, I can actually factor out a negative 2 from over here. So we have minus 2, then x square, then subtract 2x, add this with 1. Still going to equal 0. And now you can see from over here that I can also unfoil this out as well. And so what we have here is just x squared plus 1 squared, then minus 2 times the quantity x subtract 1, and then quantity squared equals 0. So if you notice closely with these two binomial factors and then with the quantity squares, we can actually apply the difference of formulas, but to do that we'll have to put back the 2 inside this quantity. So here, to write this even further, so x squared plus 1 square, put this back in with the square, so that means this is going to be the square root of 2, then multiplied by x minus 1, and then quantity square equals 0. Hence, we can then apply the difference of squares, that a squared minus b squared is equal to a minus b multiplied by a plus b. And so this means that we actually have to work with 2 different solutions, being in in terms of the quadratic polynomial. So put your pieces correctly. We're going to have that we have x squared plus 1. Add this with the square root of 2. Multiplied by x minus 1. It's supposed to be brackets over here. And then we do the same thing, but then except this is going to be subtract. So x squared plus 1 subtract the square root of 2, multiplied by x minus 1, and then set that equal to 0. So here we're dealing with 2 solutions, and we got to find those x values such that it's equal to 0. So, and to do so, we can actually do a little bit of distributing, since that'll make things a little bit easier for us. So let's actually distribute the square root of 2 to both of these, the quantities of the linear, binomials over here. So first we're gonna have just x squared and then plus 1. Add this with square root of 2 times x, and then minus the square root of 2. Then we multiply this. Do the same thing over here. Just distribute the square root of 2. So x squared plus 1 then minus the square root of 2, then times x, and then add this with the square root of 2, and set that equal to 0. And now let's actually group some things so that we have that it's you know, in the order of how a quadratic polynomial is written, with, you know, x squared, then x, and then a constant. So let's see, put this back in. So x squared, then we have plus the square root of 2, and then times x. And I'm actually going to group this, put it in parentheses as to, you know, distinguish it as a, you know, a constant. So we have 1 minus the square root of 2 over here, and then multiply by x squared minus the square root of 2 multiplied by x, and then add this with, now this will be 1 plus the square root of 2, and then set this equal to 0. Okay, so now we actually have two solutions that we need to figure out. Well, we have some solutions for x we need to figure out such as equal to 0. So we have to first find what values of this is equal to 0 and what value of this is equal to 0. So let's start off one by one. And of course, obviously, we can see that we can actually apply the quadratic formula as I mentioned from before. So we'll start off at one things at a time. So let me actually just use a different marker for this. So first we'll work with this quadratic polynomial over here. So x squared plus the square root of 2 times x, and then add this with 1 minus square root of 2 equals 0. We see that, you know, we plug in the right pieces for your a, b, c, and then put that back into the quadratic formula. So we have x is equal to minus the square root of 2 plus or minus the square root of. Now, if we plug in everything back in, so far if we factor out, or not factor, if we just multiply the b squared, so this will become 2, then minus 4 times a times c, and then afterwards, we can actually just distribute that 4 into all of this, since we're also dealing with the 1 minus square root of 2 as the constant as well. So we have plus 4 times the square root of 2, and then subtract 4, all this being divided by 2. Simplify things even further, so we have minus square root of 2. So I'm just simplifying this part out. So we have 4 times the square root of 2, and then subtract 2 divided by 2. We can even simplify things even further, that I can actually factor out a 2, then take that square root, and so outside that will be multiplied with the square root of 2. So minus square root of 2, add or subtract the square root of 2, multiplied by the square root of 2 times the square root of 2, and then subtract 1, and then divided by 2. And if you want to, you know, if you want to simplify things further even there, we can actually just, you know, this will be the square root of 2 on the bottom, so it's just like undoing it from like multiplying the square root from the denominator. So we have negative 1 plus or minus the square root of 2 times the square root of 2, subtract 1, and then all this being divided by the square root of 2. This is a real solution, of course, so that's cool. But let's actually figure out if there's any real solutions existing for this quadratic polynomial over here. So we do the same thing over here. So x squared, now it's minus the square root of 2 times x, then add this with 1 plus the square root of 2 equals 0. So we do the same thing, quadratic formula. So x is equal to, so if I plug this back in and then simplify it out, so we're going to have this positive the square root of 2 plus or minus the square root of 2 minus 4 times the square root of 2, then minus 4 divided by 2. Then if I simplify this out further, that means square root of 2 plus or minus, so I'll put the leading negative 4 times the square root of 2 minus the square root of, or not square root of, this is actually just going to be 2, and divide by 2. Then if I just factor this out, we can factor out the negative 2, but I think you can already see where this is going, that that's going to be an imaginary solution, but that also means that we're finding real solutions. We can actually disregard this entire thing, but for the hell of it, why not? Let's actually just solve this out and see what the imaginary solution is. So we have the square root of 2, and then, so this is plus or minus the square root of 2 multiplied by I times the square root of 2 times the square root of 2, subtract 1, and then divided by 2. And if you just want to do the same thing just like before, because the similar format works as well. So we have that x is equal to 1 plus or minus I times the square root of 2 times the square root of 2, subtract 1, divided by the square root of 2. And so just like that, we have found our real solutions, and that the only real solution that satisfies this following is just this part, the positive, or rather negative 1 plus or minus the square root of 2 times the square root of 2 minus 1 divided by the square root of 2. Now, if we were being asked to find all solutions, so that I also have to include the complex, solutions as well, then we can also box this in if we want, but that's not the question that we're being asked for. But if you're curious to know what all the solutions are, we have 4 different solutions, 2 in each. 2 of the imaginary solutions and then 2 of the real solutions. Combine that together if you'd use some set theory, and then we have found our solution that satisfied this quartic function. So yeah, that's pretty cool if you ask me.